So hi everyone, my name is Paulina, and today I would like to introduce you architecture components. Okay, so one word about me. As I said, my name is Paulina. I came here from Wrocław in Poland, where I work as an Android developer at Droids and Roids company. And I'm also the co-organizer of Toast Wrocław meetup, that meetup for Android developers. And I'm also leading the GDG Wrocław and Women Tech Makers program. You can find me at Medium, at GitHub, at Twitter, and in many other places probably. Okay, so what we'll talk about today. So basically we'll start with introduction to architecture components. What are architecture components? Lately I will briefly just discuss the room, and later lifecycle aware components like view model, LiveData, and lifecycle components. If I will have enough time, I will try to show the simple application architecture, but we'll see. Okay, so what are architecture components? So on a Google I/O event in May 2017, there were announced a set of libraries called architecture components, and in this set of libraries, there were announced smallest libraries like Room, a library for data persistence, lifecycle components for handling lifecycle of UI, LiveData, which is basic lifecycle aware data holder, a view model for storing our data for activity or fragment, and paging library for pagination with recycler view. So that was in May 2017. At this year, Google I/O, there were announced two more components, like navigation components for handling navigation, and work manager for handling background jobs. Okay, we'll start with Room firstly. So Room basically creates abstraction layer over SQLite, and so we can use database in a very easy way. In Room we have three main components like entity, DAO, and database, which are for storing data and accessing this data. Okay, so we may ask ourselves a question, why another database library? Yeah, because we have many solutions like native SQLite or Ormlite or any other databases like Realm. So why another one? So firstly, Room is cool because we have barely no boilerplate code. Yes, we don't need to write the SQL statements on our own. We just use the proper annotations. The second cool thing is that our SQL statements are validated during compile time, not runtime, so there will be no runtime exception caused by some SQL typo. The third thing is that there is full compatibility with LiveData and RxJava, which is cool, and Room is just easy to use, test, and to migrate. Okay, so how to use it? Basically, we need to start with entity, and to create entity from a simple data class, we need to add just two things. The first one is an entity annotation, and the second one is primary key, and that's all that you need to do to create entity. To access entity, we need to create a data access object, DAO, and for creating DAO, we just need to use the DAO annotation, that's obvious. And in DAO, we can have many methods for inserting, updating, deleting, and so on, and of course for querying our data. And one thing about querying cool is that we can eject SQLite code into Android Studio, so we can just see the syntax suggestions and so on. So it's pretty cool. And of course, we can use some SQL syntax for accessing data with parameters and so on. Okay, now we have entity, we have DAO. We need to bind everything together, and to use it, to make it work, we need to use database class. So to create database class, of course, we need to use a database annotation. Second thing is that we need to extend over Room database class, and we need to have at least one method that is returning a DAO object. Thanks to this, we can use the database builder for creating our database class. And after this, we can just easily use room, for example, for inserting or accessing our data. Okay, so testing. How does it look like? So testing is pretty easy with room because of the in-memory database builder. And thanks to this builder, we have just database that is the same as our original production database, but it's just in a separation. Yeah? So we don't need to worry about the data in our production database. We can just make some inserts, deletes, and so on, and test them. So the example test can look like this. So for example, we can just insert some data, then we can just select them from the database and check if they're equal. So to summarize the room, room is cool because there is almost no boilerplate code. As you saw, the only SQL statement I need to write is just the select statement. The SQL statements are compiled are validated during compile time, not runtime. There is compatibility, which I will show a little bit later, and room is easy to use, test, and migrate. If you would like to hear more about room, there is a presentation tomorrow by Magda, so I encourage you to check this. Okay, now it's time for lifecycle-aware components. So as a developers, we know that handling lifecycle of UI of activity is pretty painful. Yeah, so we need to remember about registering, unregistering, start and stop, and about activity recreated, caused by orientation changes. Yeah, and if we are pretty unlucky, we also know this schema on the right, called also a LOL cycle, and we know that this is not something that we'd like to handle. So that's why lifecycle-aware components were made for. So basically, we have two components. We have lifecycle owner, which is basically anything that has a lifecycle, like activity or fragment, or anything based on this, like a compat activity and so on. And on the other side, we have lifecycle observer, which is basically anything that is interested in observing lifecycle changes. And lifecycle owner can be in 4 different states. So initialized, created, started, resumed, and destroyed. And between those states, he can emit events. And lifecycle observer can subscribe to observing those changes, so we'll be notified every time there is a change in a lifecycle. And this is an example from a code. So let's imagine that we have some activity, and in this activity, we'd like to have some kind of location manager or something. So we need to write a lot of the code, for registering and registering, and this is the part that we are really interested in, so the location changes. To get rid of this boilerplate code, we can transfer our location manager into a lifecycle observer. So what we need to do is that we need to pass somehow a lifecycle owner, which is an activity, for example. We can add ourselves as an observer to the lifecycle of this lifecycle owner. And thanks to this, we can use annotations to subscribe to observing changes in a lifecycle. So, for example, we can just say that on start we'd like to invoke this method, and on stop something different. Thanks to this, code of our activity will change from this into this. So, as you can see, in activity there are left only things that we are really interested in. And that's what Git Boyer, one of the creators of architecture components, says about this. So it's really that location manager is interested in observing lifecycle state, so it should be able to do it without the activity babysitting itself. Okay, now something different, view model. So let's assume we have some activity, and we need to because we don't want to store the data in the activity. We're good developers, so we need to have some external data source. It can be, for example, a presenter in MVP approach or view model in an MVVM approach. So basically, we have some external data source. But unfortunately, after rotation, the activity is recreated. And this data source should be or could be destroyed with this, and in place of this data source there will be created a new one. So the question is that what should happen, or what could happen with this data that will be stored in a data source? Yeah? If we'll destroy this, when activity is destroyed, we will lose all the data, and we'll probably need to make some second call to API or database or anything. And yeah, that's a waste of resources. So that's why ViewModel was created for. So ViewModel is basically a source of data for our activity or fragment that is independent from the activity. So it has its own lifecycle, and thanks to this, after activity is recreated, we still have the same ViewModel, and we don't need to worry about this data. So at first, we don't need to worry about this UI data source itself. So we don't need to worry about creating, destroying, finishing. Yeah, we don't need to worry about memory leaks and something like this. Second, the data will wait for us. So for example, if we make some call to API and the result will be back before the activity will before the activity will be recreated, then we will know for sure that the data will be wait for us in a ViewModel, and we can use it after activity is recreated. And the data will be always updated even after activity recreated, as I said. Okay, so let's look at the code. To create ViewModel, we just need to extend ViewModel class, and that's pretty all. Now we can store some data in this ViewModel class, for example, a list of the strings. And we can, of course, have we can have context of the application in a ViewModel if we would like to. We can just extend the Android ViewModel class. Yeah, and to use a ViewModel in activity, we need to use the ViewModel providers class. And that's where the magic happens under the hood, so we don't need to create this ViewModel on our own, and we don't need to handle its lifecycle. It will be done by the library. So thanks to this, we can just get some data that we stored previously in a ViewModel, and we can show this, for example, on a UI. Okay, LiveData. So LiveData is basically lifecycle-aware data. So let's take an example of the list of the string. So we can just wrap this list of the string into LiveData, and thanks to this, our activity can observe changes that were emitted in this list, and we can notify every time there is some change in this event. And it's pretty cool because all of this is lifecycle aware. So all of this happen only if activity is at least started. So we are sure that if activity is stopped, then we will not be notified about new data. And now the code. So to use LiveData, we'll just use the example from a previous screen. We will just simply wrap list of the string into this LiveData. This is mutable LiveData. It's just mutable version of LiveData because we want to change these values inside of the ViewModel class, but we'd like to expose just LiveData to not allow anyone to change these values. And now, for example, we can just subscribe to some changes from API, for example, from some external repository. And whenever new data comes, we will just post this value on the UI. And to use it in activity, we'll just make a small change. So now, instead of getting the data every time we'd like to show something on UI, we will subscribe to observing those changes. And whenever something new comes, we will just show this on a UI. So as you can see, it's simply observer pattern, but with lifecycle awareness. Sometimes there is a need to transform our data in a ViewModel. We can use transformations to do this. So for example, we have list of user, but we'd like to expose only the names of the user. So we can use just simply transformations map, and we can just create new LiveData based on the old LiveData. Okay, now LiveData with data binding. So let's assume we have data binding in our project, and data binding allows us to bind the UI components in the layouts to the data sources. Yes, so we can use the data source, and we can set the data directly in the XML instead of setting this in an activity, for example. So as a data source, we can use our view model. And for example, when we want to set some view, we can use just the data from the view model class. This is how view model looks like. So as you can see, we have some observable fields. These are from the data binding library. And we need to notify that every time something new comes, we'd like to set this value. But what if we put the application into the background and the result from repository will come after this? So unfortunately, data binding is not lifecycle aware, but LiveData is. So there is a support for data binding with LiveData, and we could just simply change observable fields into LiveData. And thanks to this, we are able to do the same thing as with data binding library, but it will be all lifecycle aware. In the activity, the change is very small, so we need to just set ourselves as a lifecycle owner to tell that we are lifecycle owners, and that's pretty much all. Okay, as I said, Room has support for LiveData and RxJava. So, for example, if we have some select and we return the value of LiveData from this select, we have two things for free. So first one is that we will have the observer pattern. So whenever something changes under this select, so the list of the cats will change, we'll be notified about this. And the second thing is that we don't need to worry about the threads. So we can call it from whenever thread we want. Okay, so too long didn't read. LiveData is cool because it keeps our UI always updated because of the observer pattern. And there is, all of this is lifecycle aware, so we don't send the data into the activity that is already stopped. Okay, and I have 2 more minutes, yeah? So, okay, I have simply architecture example. I can just show this very, very briefly. So we can use architecture components in the simplest way. We can use just MVVM architecture. So in MVVM, we have model, view, and view model class. View is, of course, our view like activity fragment. View model is view model as I shown previously. And model is some kind of a repository. Yeah? It can be, for example, local repository, like we can use Room, or some remote repository like API, and we can use retrofit. It doesn't matter, it's just the abstraction layer over some fetching data. And, okay, I will just try to show it. Okay, maybe I will skip the slides. Okay, so here we are in an activity. And as you saw, there is a view model created, the same as was before. And we can subscribe ourselves to observing changes in this list of kitties, for example, and we can just show them on the UI. So in a common approach is that we have, for example, a master detail view, yeah, and we have some kind of list, for example, and whenever we just select something, we'd like to show the details of this thing, yeah? So we need to have some data, we need to fetch this data from some repository, and we need to show these details on the UI. So, for example, we can just set simply click listener, and we can tell vModel that we'd like to request the details of the kitty. And in our vModel, we can just store many LiveData as we want, and we can just fetch the data from some repository, and we can just post this value to the UI. So as you see, we have all the data that are needed for our UI stored in one place, in a vModel, all of this is lifecycle aware, so we don't need to worry about checking if activity is started or not. And all of this is very easy to test. Yeah, and in our activity, we can just subscribe to observing those changes. Okay, I have also the test example, but I will just put this on a GitHub repository because I'm out of the time. So yeah, these are resources that I used, and thank you.